Hello everyone, welcome to Chemistry Time. Now we will be studying and unleashing the concepts of chemistry in this online lecture series. Today I begin with chapter number 1, actually an introduction of the chapter in this part. I hope you benefit and gain knowledge through this lecture series. Thank you. Beforehand, I would like to inform you that you have to stick to your textbook, Concise Chemistry, Class 10 ICC. You'll be following this regularly, and I expect that each and every one of you regularly read the textbook. After the online lecture, after the online class, you should be reading through. Try to solve the questions, practice the questions as well. Here is a motivational piece of code for you. Follow one course until success. That makes up focus. You need to be focused towards your goal. Whatever your goal, you have to achieve that. In order to be successful, you have to be focused. Stay focused, you will be successful definitely. Let us begin now. Chapter number 1, periodic table, periodic properties and variation of properties. Beforehand, what you are going to learn in periodic table will be related to elements, and elements are actually we are studying in chemistry. There is a basic definition written there. The study of substances and their transformation is called as chemistry. Study of substances, we are studying substances and how they are transforming or changing from one form to another. So ultimately we can say these substances being classified into 3 parts: elements, compounds and mixture, and these elements are more than 115 in number. This is a huge number, and if we go to study them individually, it would be almost be impossible to learn or memorize each one of them. So what is the easy way? How do we study more than 115 elements? The answer lies in the fact that we can classify them into categories, classifying them, making small groups, and it will make our task easier. We can relate this to real life examples. For example, in a library, books are arranged in a proper manner. Chemist shop, medicines are arranged properly. You ask for one medicine, you get easily. The person is not searching here and there. Retail shop, you can find all the things are properly placed in their proper place. So if we arrange these elements, more than 115 elements, in a proper manner in different groups, it will be easier for us to study them. That is what we are going to learn in this chapter. Let us have a look at the earlier attempts to classify the elements. The first successful attempt was done by Dobrynin. Here we have placed the photographs of both famous scientists, Dobrynin and Newland. Dobrynin, what he did, he made groups of elements into form of triads. Triads means group of 3 elements together, and these elements were placed in such a way that the atomic weight of the middle element was the arithmetic mean of the other 2. Let us have an example here to make it more clear. For example, calcium, strontium, barium were placed in one of the Dobrynin's triad. Calcium having an atomic mass of 40, strontium having an atomic mass of 87.5, and barium 137. If we do the average of the atomic mass of the first and the third element here, that is calcium and strontium, it comes out to be 88.5, which is more or less similar to the second element, that is 87.5. So that is what it is being told in this statement, that middle element atomic weight is equal or almost equal to the arithmetic mean of the other 2. The second successful attempt was made by Newland's law of octave. In this, elements were arranged in an increasing order of their atomic mass, and every 8th element resembled the first element in the physical and chemical properties. This was a short kind of a periodic table only, but it couldn't be more successful. Both Dobrynin's triads as well as Newland's law of octave, both of them failed later on, because at that time when they were discovered, there were not much known elements. As more and more elements were discovered, they could not be placed as per this rule, and therefore both of these were rejected later on. Although Newland gave his law of octaves, and it was more or less similar to a periodic table, but actually it was not. The first and foremost, the periodic table was presented by Mendeleev. Dmitry Mendeleev, he was a Russian chemist, and he gave a periodic law. It states that the properties of elements are a periodic function of their atomic mass. He classified, or he arranged actually. He arranged the elements in increasing order of their atomic masses, and furthermore, he classified those elements in the form of groups and periods. Groups means vertical column, that is top to bottom, and periods means horizontal rows, and he even predicted the existence of the unknown elements or the elements which were yet to be discovered. He left some gaps in between his periodic table, and that is why he was one of the most successful in predicting or in classifying the elements. So his periodic table was one of the most significant attempts therefore, but there were certain shortcomings. He could not explain the position of certain elements like those of hydrogen and those of the isotopes. We'll not go into much more details as this topic is that you have already studied in class 9. So we're quickly moving on to the introductory part of the modern periodic table. It was put forward by Henry Moseley and it was based on the atomic number. Now you notice the difference. Mendeleev arranged the elements in increasing order of atomic mass, whereas Moseley arranged the elements in increasing order of atomic number. Now the question may arise, what is the difference between atomic number and atomic mass? Some of you may be thorough with the basics, but I expect that everyone understands that properly, so I will deal with the basics as well. Hope you understand. So here is the diagram of helium atom. Here is the diagram of helium atom, and in the central part here it is the nucleus. The nucleus contains both protons as well as it will have the neutrons. The neutrons also are there, which are neutral. That is, they are not having any charge. The protons are having the positive charge. Surrounding this is the orbit or the path in which the electrons are moving. Helium is having 2 electrons as shown in the diagram as well. So these electrons are negatively charged. When we are talking about the atomic mass, it is actually the number of protons plus number of neutrons. As shown in the diagram, there are 2 protons and 2 neutrons. That's adding 2 plus 2 will give you 4. And that is what is shown here is the atomic mass, or A. Capital A is the symbol for atomic mass, that is 4 for helium atom. Another thing that is written here is 2. What is this? This is the atomic number. It is represented, atomic number is represented by Z. So this Z or atomic number is equal to the number of protons. It is sometimes confused by number of electrons. It is partially correct if the atom is neutral. Yes, you have to be careful. Atomic number is the number of electrons only and only if it is a neutral atom. If we are talking of any ion, it may be cation or anion, and then we will not say number of electron equal to the atomic number. So, for an example, sodium atom, it is having 11 atomic number. 11 atomic number means 11 protons. Also, normal sodium atom has 11 electrons. If sodium atom loses 1 electron, it will form positive ion. Then loses 1 electron, then 1 electron is reduced. That is, it will have 10 electrons. That is, it will have 10 electrons. But the number of protons does not change. That is why, if I say atomic number is equal to number of proton, then I would be wrong here. In sodium positive ion, it is having 10 electrons. That is not the atomic number of sodium. So always you will remember, if we are talking of atomic number, it is to be number of protons, not number of electrons. Moving to the next part, what is the modern periodic law? The modern periodic law says that the physical and the chemical properties of elements are the periodic function, means the properties are repeated of what? Their atomic number. This statement is more or less similar to what Mendeleev stated. Just notice the difference here is with regard to the atomic number. The extended form of periodic table which we refer to these days was given by Niels Bohr. Now here is an important definition. What is a periodic table actually? I've been talking about periodic table, but actually what it is a tabular arrangement. We are arranging the elements in a tabular form, and this tabular form contains groups and periods which will highlight, or it will reflect the regular trends and the properties of elements. Just you will have a look on the modern form of the periodic table. Here it is. This is the modern form of the periodic table. You can refer to it in the book, the textbook itself, on page number 2. Here you can see their elements are regularly and properly arranged in various groups. You can see here the color code is given at the bottom part here. You can refer to this. The first one, this shows the alkali metals. These are over here, group number 1. Next one, alkaline earth metals. This color code is shown there. The remaining these part is actually transition. What these are, we will deal with this just in this class itself. Followed by this are the basic metals. What are the following one are the basic metal. These are all forming the basic metal, the green ones. Followed by this, we have the metalloids. The metalloids are over here, the blue ones. These are the metalloids. These are actually semi-metal. These show partial properties of metals as well as non-metals. These boron, silicon, germanium, and so on are a part of this. Followed by this part is actually of non-metals. Over here, you can see the color code. These are carbon, nitrogen, phosphorus, oxygen, sulfur, selenium as well. So these are all the non-metals. Followed by the halogens. These are salt formers. We'll deal with this when we'll study the group. Fluorine, chlorine, bromine, iodine, and so on. The last one, last but not the least, helium, neon, and so on. All these are the noble gases or the inert elements. Let us have a look at the salient features of the modern periodic table. Before we begin, let us recapitulate the definition of periodic table. What is a periodic table? It is the tabular arrangement of the elements in groups and periods. So now what we are going to do is we will individually look at the groups and the periods one by one. First of all, what are the groups? Groups are the 18 vertical columns. The modern periodic table contains 18 columns, and these columns are called as groups. Each of the group has elements where the number of electrons in outermost shell is same. That is, the valence electrons are same or equal in each of the group. For example, group number 1 contains hydrogen, followed by lithium, sodium, potassium, and so on. Hydrogen having 1 electron, lithium having 3 electrons, sodium 11, and potassium 19. If you write the electronic configuration, KLM cell and so on, then what will it come here? 2, 1, here it is 2, 8, 1, here it is 2, 8, 8, 1. Now you notice here the last number of electron is always 1, that is the valence electron. So in a particular group, the number of the valence electron is always same. So this is giving us a new point as well. The number of valence electron is same for a particular group, and therefore it will also indicate the group number. So that is, if here in the periodic table you can see here, all these elements, group number 1, are having one valence electron. So they are belonging to which group? 1, because number of valence electron is also 1. The second one, group number 2, so valence electron will also be 2, followed by group number 13. So don't say 13 valence electrons. I hope you know the octet rule. Go back to your basics in class 9. So group 13 will have 3 valence electrons, group 14 4 valence electrons, group 15 5 valence electron, group 16 6 valence electron, group 17 7 valence electrons, group 18 8 valence electron, and that is 8. 8 means octet is complete there, and therefore they are noble gases. Coming to the next, one more thing here, example is given here. Lithium, for example, 2 1, that is the electronic configuration. Outermost electron is 1, so group is 1 of first A. Second one, nitrogen having 7 atomic number, electronic configuration is 2 5. The outermost electrons are 5 in number, therefore it is group 15 or 5A. Followed by argon, that is a noble gas, so 288 comes the electronic configuration, and therefore because of it is having 8 valence electron, it is in group 8A and group number 18. You may be worrying what is 1 and 1's first A, 15 fifth A. See this, wherever this A is written, that is from the old form of the periodic table that was given by Moseley. Whatever is given here, the 1, 15, 18, that is the long form of the periodic table. That is the long form of the periodic table given by Niels Bohr. Individually now, one by one, we will have a look at the various groups. First of all, the group number 1. Group number 1 is having the alkali metals, because whenever we are mixing or reacting this with water with H2O, they will form strong bases or alkali, except hydrogen. Hydrogen is an exception there in the periodic table. These are the elements name already we have discussed in the classroom. Few were present that day, and I hope those who were there have already memorized these. I expect everyone to learn these elements in individual groups. There are some short methods already discussed in the class. I will not be repeating it here though. Followed by the group number second is alkaline earth metals. Group number 3 to 12, they are called the transition metal. Transition in English language, the meaning is change. So what is changing over here? Let us have a look here. What is changing over here? You see here the group number 1 and 2 are generally metals. This side more or less we are having the non-metals. Here it is non-metal. So metallic character is changing to non-metallic character. Followed by this we have the group number 13, 14, 15 and 16. Here we have a special characteristic that these groups are named after the first member of their group. These are named after the first member of their group, individual group. Whatever the first member, you can see here B for boron family, C stands for carbon family, N stands for nitrogen family, O stands for oxygen family. So group 13 is called the boron, 14 the carbon, 15 the nitrogen and 16 is the oxygen family. Individuals you have to learn. Again I repeated this. Now here group number 16, another common name has been given to this is the chalcogens. They are also called the chalcogens. This term means they are ore forming. Followed by the group number 16, we have the group 17. It comprises of the halogens and therefore called as the halogen family. Halogens, I have not written the names here. These are fluorine, chlorine, bromine and iodine. All these fluorine and chlorine are actually gases, followed by bromine. It is actually liquid and iodine is a solid and it is actually sublimating. It can form vapors as well. So the liquid and the liquid non-metal, you have to remember this to be learned. The liquid non-metal is bromine. Apart from this, another important thing here, they are called halogens because the term halogen means salt forming. They are generally present in the form of salts. For example, chlorine forms NaCl. Also bromine forms NaBr, sodium bromide, sodium chloride, NaCl. So another examples also you can relate to. Followed by this is the group number 18, that is the zero group. And they comprise of the noble gases or the inert gases because their outermost orbit or the valence shell is fully complete, the octet is complete, and because the octet is complete they generally do not react with other elements. So the summary is given here again. Group 1 to 17, all these are called as the main representative or the normal element. They are the main group elements. It can comprise metals as well as non-metals, especially group 1 and 2 are metals. These are metals, followed by the non-metals. The group number 18 are the noble gases, and in between the group 3 to 12 are the transition elements. Now we'll move further on towards periods, that is horizontal rows. In the modern form of periodic table, there are 7 horizontal rows called the periods. In this, the number of electrons in the valence shell is increasing. Remember, in the valence shell, number of electrons is same in groups. In the case of periods, it is increasing. Just for an example, I've written here the second period. The second period mentions here that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Now notice here the elements are from atomic number 3 to 10, and each of these electronic configuration is mentioned here. Now here the valence electron, the second one here, is changing here. 1, 2, 3, 4, 5, 6, 7, 8. So that is the number of valence electrons are always increasing from left to right in a particular period. From this we get to remember an important fact. This is, you have to remember, period number is equal to the number of shells present in an atom. Now here in the above example here, the number of shells are 2. One shell is having 2 electrons, another one is having the valence electrons. That is different for different of the elements. So because 2 shells are there, therefore the particular element will belong to second period. If 3 shells are there, third period. 4 shells, 4 period, and so on. So that is, you have to remember, the period number shows the number of shells present in an atom. One extra point is there, that is lanthanides and actinides. These are not included in the main form of the periodic table. The lanthanides are contracted at group number 3 period 6, and actinides are also contracted as at the position of group number 3 period 7. They are not included in the main periodic table. The question arises, Why is it so? The answer is because if we expand these all, it will disturb or distort the main periodic table. The shape of the periodic table will not be proper. It would become almost impossible to arrange all the elements together. Also, all the lanthanides more or less show the similar properties as do the actinides as well. Actinides are actually radioactive in nature. Will not go into more details of this fact. So that is all for the introductory part of the periodic table. Go through this periodic form of through this long form of the periodic table in your textbook, and you have to memorize this main group elements, especially the group 1, 2, and 13 to 18. These groups you have to remember. Apart from this, one thing I have missed here and not mentioned in the notes, that is this particular group. The particular period number 3, that is having sodium, magnesium, aluminium, silicon, P, phosphorus, S, sulfur, Cl, chlorine. This here argon is not coming up to chlorine only. These elements are called as typical elements. These are called typical elements. Why they are called as typical elements? The question arises, what is the reason they are called typical elements? Because they summarize the properties of their respective groups. Sodium will show the respective properties of the remaining elements. Similarly, magnesium shows the property of remaining elements, and so on. So typical elements are in the in the period number 3 of the periodic table. That's all for the lecture today. One question now after the chapter we have discussed here, whatever topics we have discussed, one question based on that is there. Here we have been given a sulfur element. Its atomic mass is 32.